আর স্যার সাইডে যেটা করেন স্যার, যদি স্যার আপনি চা খান তাহলে স্যার ওই মানে যদি আপনি গ্রিন টি খান স্যার, তাহলে গ্রিন টি এটা নিয়ে আসবেন আপনার পছন্দ স্যার। কেটলি ভালো থাকে, জল গরম করে আপনাকে
কেটলি ভালো না,
মানে
ওকে ব্যবহার করে না হচ্ছে, আমি খাবো না চা।
বলছি অনেক সময় গ্রিন টি খান,
হ্যাঁ
বললাম সিস্টেম অনেক খায়।
Sir, no voice. Voice नहीं मिल रहा है. No audio. इसको रात हो जाएगा तुम्हारे बिल्कुल भूल जाएगा लग गया नहीं चलेगा अभी बढ़ाते नहीं आवाज वो बोल तो रहा है नो ऑडियो
आवाज नहीं आ रही है सही
हाँ
से।
नहीं बोल तो रहा ना ये दिखा रहा ना फ्लक्चुएशन दिखा रहा है बोल रहा
ऑडियो सर,
आवाज नहीं आ रही है क्लियर।
तो सुनना चाहिए तो कह रहा हूँ
Hello, anyone please respond?
Sir, now getting voice, sir. Your voice is clear, sir. Now.
1 minute.
Good morning, sir.
Yeah, one. So you can copy.
not get रहता है हाँ?
Sure.
Can you hear me on the call?
Yes, you are audible.
Voice is breaking. It is not clear. Voice is breaking.
So thank you for the opportunity to explain and to work with Indian Railways to design and work on a migration journey. And maybe bandwidth is less. Okay. So the migration journey from TDH as a TDM and SDH to IP MPLS. Myself and Sumit, we have worked out a slide template on understanding what railway services are. These are based on our understanding on how railways is working, and we have been working in multiple different zones, Southwestern Railway, Western Railway, to some extent East Coast Railways. So whatever understanding we have gathered on the applications which railway uses and how to migrate this application and the journey of the application migration, then the transport migration. And once this entire migration is achieved, what are the key architecture important roles technologies which you have to adapt. So based on those, we have created some slideware. But I would like this to be a more interactive session, as there could be some assumptions which are incorrect. I would need your help to correct those things. And there would be something which I'm missing. Please do feel free to add on this. Thank you. So Cisco has been predominantly working in a large amount of legacy transformation. Over a period of last 20 years, we have almost transformed and helped the customers in migration journey from SDH. Majority of the migrations across the world of SDH has been finished by, I think, last 6 to 7 years back. There is some amount of SDH migration still happening in India and in some of the Asia Pacific countries, and that is the last leg of SDH which is going on. So because of this vast exercise, the presence of SDH and the cost of SDH and the skill set across the SDH domain has gone up, and SDH vendors also have reduced quite a bit. Majority of SDH vendors make in India or international vendors are moved to something called as MPLS world and MPLS. Some have adopted MPLS 3P, some have adopted completely IP MPLS. So there has been multiple different technology migration journey which is happening, which is helping SDH migration to move to Ethernet. MPLS as a subset itself has okay. So what triggers this migration is not an end of era for SDH or not IP MPLS as such. Usually the migration is triggered by application change. There's a majority of applications which are shifting on the way they communicate with their servers and with their users. Right? In railways also we have seen in signaling SCADA is in some of the railway SCADA is majorly migrated to Ethernet. Right? Majority of your applications other than a few applications, and please do correct me if I'm wrong, from block communication and train control communication, the legacy one, they are still on. The application itself uses some kind of sub 64 kbps and sub 2 mbps circuits to communicate. Right? Other than this, RailNet, passenger reservation service, voice, CCTV, all these major services have already migrated to Ethernet. Their core architecture is on Ethernet. They run on Ethernet natively. But because of the railways USDH architecture, architecture, they have still been having the journey. Some of them still having the journey on the even, right? So these all migrations, we will see how these services migrate over a period of time.
To add what Binu is saying, so essentially we need a network which is Ethernet rich, but that at the same time we need a network for the backward compatibility. Like if you have RS485, 232, E1s, we'll need that support also. So we are in the mid of a transition, so we'll require support for Ethernet as well as the backward compatibility also. So our solution is being designed keeping that in mind.
There are some of the key challenges for Indian Railways is the kind of architecture the railways are in. So when I say kind of architectures, railway is divided into zones, and each zone has their own implementation mechanism. It is although all zones are interconnected to each other, and you have a very robust network and network with multi-path diversity. Few of the railways maps which I've seen are really very resilient on path. But the migration will have a challenge in terms of how the paths are being obtained. Like one zone going into a MPLS, another zone still remaining on TDM will still see the migration challenge, and having STM interface at the border zones where we connect with internet and a non MPLS Ethernet and a non Ethernet kind of a network. So there is going to be challenge. But from a network point of view, from a network architect, what I see is a very highly resilient network can be created. The amount of part diversity, the amount of fiber network infrastructure, the amount of telecom infrastructure which is already in place makes railway very suitable for this migration journey. Yes, the process, of course, will be a bit complex. There's a shift of technology happening from click, point, and provision to command line interface for each configuration is a journey. There are ways and means to overcome this journey. We will cover some part of that also, although it is not covered in the RDSO and all, but we understand from automation is last 5 years automation has taken a lot of difference. This is one important dependency of on external third system integrators, and the skill set of system integrators also play a very critical role when these migration journeys happen. So how do we create a network which needs minimum amount of interface from external third party, and how do we enable railways in themselves to control and manage the internet? So those are the aspects of our focus. Yes. So I will jump few slides here. I hope the slides have updated in the WebEx. We have highlighted some, our understanding, we have highlighted and categorized a few of the services. And these services are from your parcel management, your cabin information system, to the VoIP-based train control communication, to RailNet, SCADA delivery, data logger connectivity, block communication, TCAS coming into play. What was that? Kavach coming into play in a bigger role in railways. How do we integrate all together into one network ecosystem without adding up equipments, a layer of equipments of everything? That is a beauty of MPLS and Ethernet network, that they can consolidate and do a lot of statistical multiplexing and give you the bandwidth and manageability. So these are some of the services which we have understood from our interactions, and we see how the migration journey would be over a period of time. I will take a pause here to just, if there is some corrections here which you would like to point out, something which you think is not the right thing, or you think we have to focus on different, please do let us know.
Any services which are missing?
Any services which are missing. Yeah. So this is natively the application structure. So natively it is all Ethernet. Although because of the unavailability of Ethernet over SDH ports, and majority of these services are using Ethernet, but they are natively Ethernet. So when I move into Ethernet, they will maintain their state. So I don't have to change the state of application, right? Where the state is changing, that's few points we have highlighted, and that is where we need your help to understand whether data logger can by state convert into Ethernet or not. Will it still remain even? Because
So that is what I.
Excuse me, sir. There is a problem in audio. We are not able to
right,
get the
That is what I told
content
you. We are
properly.
designing a hybrid system which on the access side supports Ethernet, your PDH interfaces like RS485, 232, X.21, and events at the back end. Now, when we talk about LGS system, it's primarily a TDM network, E1, STM1. We are talking about MPLS network. On the backhaul side, it will be Ethernet. At the access side, it will give you flexibility of including your applications which may be migrated to Ethernet in going future, and you are running 485 kind of SCADA systems or 232 or EMM ports. So all those things can be brought to a box, and your uplink can go over a packet. The whole idea of discussion is that how can I accommodate those legacy technology and upcoming technology. As Binu rightly pointed out, everything has to migrate to Ethernet in future. But in
Sir, Venu Nair sir, please check up this voice is not clear, please.
सर ऑडियो नहीं मिल रहा सर आपका.
So WebEx, the team on WebEx, is the audio clear now?
Now it's better, sir.
Yes sir, now it's better.
Okay, okay, sir. Thank you. So as we highlighted, these are the services which we think
हट गया.
one. Yeah.
It's fine now.
Is it fine? I will, sir. Take time. Network is.
Share, you are not sharing. You are not sharing. You are not sharing.
Sharing of your screen.
So come to the website. WebEx, come to the WebEx. What is share?
दोनों में नहीं हो रहा. Share is like this one. Yeah.
What can be done? Put it in PPT.
PPT mode में ही है.
नहीं इसमें pen drive में डाल दो. We can put it there. I can run the slides for WebEx, and you can do the presentation.
It will come in this side with this way only if I.
अभी आया सर, अभी आया सर.
हाँ, correct, sir.
So it's like this one.
Don't concentrate on this.
Yeah, Nikam, yes.
No, you continue. You continue what it is. You continue.
Go to the display settings.
You see that screen and then you just. Now you
Okay. So these are the few services which we. These are the few services which we think are the key services for the change on application side. This is a basic connectivity architecture, how services will be connected, right? So this is a basic base station router, and this has a SDH connectivity to it will come into the even port. So there is a even card, 8-port even card. This could be different kind of cards, 32, 16, 48, whatever you want, whatever configuration you want. But as we do the journey to MPLS, and considering the cost which Indian Railways has to incur, the lower the TDM, the better the cost. It's vice versa. In SDH box, the cost of Ethernet is higher. In MPLS box, the cost of TDM is higher. So that is why we are focusing on natively on the applications to understand what applications would bare minimum need events, and we will only migrate those applications as even into the MPLS world, and whichever application can natively be on Ethernet, they all will come on Ethernet service as a service.
Are you able to hear the difficulty? You all are able to hear.
Voice more.
Just speak louder.
Okay. Okay. So this is a typical architecture of station networks. So we will look at how the services are connecting. So this is the service flow. Currently you have PRS, voice. These are the external services which run on the on railways network. So these services will there are two ways to migrate these services, and we have some detailed slides on these particular service migration as they come on to railway backbone. How to ensure that their state is maintained, which means that the migration is done on the same protocol, same configuration, same IP mechanisms, and we ensure that a seamless migration happens. At the same time, we reduce the dependency on different service providers and bring it on all back to the backbone of railway network. So if you here see, this is your LER MPLS router, and this will connect to L3 switch or L2 switch, depending on different railways will go for different kind of requirements. But we always suggest go for a L3 demarcation boundary. Reduce your number of L2s which will come and land onto the MPLS. That is a major aim. Reduce the number of L2 domains which will come directly and hit the routers, because whenever you increase the number of L2 domains to come and hit, it exposes kind of different, it brings its own challenges onto the box, right? And this is your core infrastructure. Although we have mechanisms, so in the world of MPLS, there are n number of mechanisms, botcat, storm control. There are a lot of things you can do, ACLs and all. But the more things we fine tune in configuration, the more the complexity in troubleshooting. So network has to be designed in such a way that the troubleshooting has to be fast, quick, and efficient. So the more we have ACLs, the more we have route policies, the more we make configurations onto the box, the difficult the troubleshooting becomes. So that is why we want the L2 boundaries to be taken off from the router, demarcate at a L3 switch, terminate all your Ethernet services in different VLANs. This will be Wi-Fi services, CCTV services, RailNet traffic. Everything will come to this L3 switch. From the L3 switch, we will have a L3 direct connectivity to the MPLS router. So that's how we will demarcate the boundaries. This is suggestion. That's how it will be better managed.
One more thing will help, that it will reduce the number of cablings you do at the station. You start drawing cable from each end point to router. That will be again a mess, and managing those will be again a challenge. So this will help in reducing the cabling part also.
Yes, and the L3 switch can be kept, not necessary to be kept in the telecom hut. It can be kept very closer to the applications or where the services are running, and you just need a uplink fiber cable from the L3 switch to the MPLS router. So the number of equipments coming in the telecom hut room can also be minimized, which will means that the L3 switch can be now non-hardened. So it can be, now it doesn't need to have a 65-degree operating temperature in a hardened environment, which is telecom hut rooms typical layout is. Apart from this, the PDMux has to slowly taken out. Now how we will take out is depending on what kind of services are running. Anything at 2 Mbps can directly come to the router. So we have got a starting from 8 port all the way to 48 ports, even ports capability is there in one slot. This is the way station. Junction will have a different configuration. Way station, we want to keep it less costly and lean and mean configuration box. So anything on 2 Mbps can directly come on to this box. Anything which is not 2 Mbps or sub 2 Mbps, 64 kbps, 8 kbps, those kind of circuits, we'll have to see how and what those interfaces on those boxes are. There are some interfaces which are natively supported on the router, like Sumit said, RS232 and FXO. There are a lot of ENM, lot of cards which we are support on the TDM, but then it will increase the size of the box also. So could be we still use your PDMux if there are sub 2 Mbps applications. We still use the PDMux and bring them as a single event to the router. And those applications who can be natively on even, they can directly come and join the MPLS box. Backbone will still be your pair of fibers. We'll look into how the backbone migration. This is just to give you a view how the application will look like.
Your sound is repeating, please. Your speech is repeating, howling.
WebEx is saying the echo is coming. Okay. Is it better now?
Yes.
Okay. Yeah. Thank you. So this is a bit in detailed flow of how it will look inside the router, inside an MPLS router. How will this entire all the services would look like? So you would have segmentation. segmentation is one of the key goals we achieve when you do a migration. So we will segment all kind of applications. Segmentation makes you give more priority to the application, give QoS from the application itself. So if there is some specific application like CCTV, for example, which needs a lower loss, jitter, delay paths to be defined, the only way we can identify application is at the start only we put it in a different VLAN tag, give a priority in the VLAN tag, and then bring that VLAN tag all the way back with the same priority to your MPLS, map those priorities across. So priority is not a QoS. There are 3 bits as defined by the IETF. These 3 bits define the queue type of service bits, and they define what different qualities you can give, right? So that segmentation enables identification and prioritization of the traffic from the L2 switch all the way to the MPLS router. Once we are segmented at that level, at application at the switch level, L2 level, we bring this segmented VLANs on back to my router, and in the router I have the ability to create different segmentation for different type of traffic. So now why segmentation is important here is your backbone MPLS infrastructure would run on something called as a BGP, segment routing. These kind of the protocols will be running on for your backbone. Sorry, I'm getting disturbed by a lot of WebEx talks also in my ear. So request all of you to be on mute. Thank you. So segmentation is again important, and the key requirement is that your MPLS backbone of the railways, which is coming up now, will be running on something called as MPLS plus segment routing. So we will take a conscious call whether we have to use MPLS or we use a pure segment routing based. It has its own benefit. Segment routing, the most evolved routing protocol which is available from last 5-6 years, right? And it plays a major role in giving multi 50 millisecond, sub 50 millisecond protections and multiple different mechanisms. It also enables in future to have a control plane automation done to define the source node being able to define which application to take what route depending on the links capability. So this is not day 1, this is day 5 or day 6 in future, but yes, day 1 implementation of segment routing will enable your journey towards that position. So the control plane automation would also mean that any CCTV applications which want to traverse on this backbone of MPLS, when they reach the MPLS router, they will call out to the router saying that I am so and so application and I need 10 millisecond, less than 10 millisecond of loss jitter on my path to wherever my end path is. And the control plane having a visibility of the entire network has every links, loss, delay, jitter with it. It has the capability to decide which is the best path for itself. Unlikely the way routing protocol works. Routing protocol does not work like this, right? They have a fixed algorithm. They work in their own algorithm. They work on cost. They don't know the application's requirements. Native protocols like BGP, OSPF, ISIS. But segment routing has come one step ahead where it looks into the application. Right?
So just to add what Binu is trying to say, I'm audible on Webex or not? So segment routing gives you flexibility that how application wants to be treated itself in the backhaul. It is a source-based routing. So when a packet arrives at the router, it comes with a quality of service requirement, with a latency requirement, and segment routing. With the help of segment routing, the whole transport network treats that packet that way. And in case that delay is not met, when we go forward and implement automation, the automation engine will kick in and ensure that the delay is met, and it will change the path or whatever it has to be done. So segment routing, basic segment routing enablement, as asked in RDS specifically, also is required at day 1, and gradually we can build on that. If we miss this right now, the segment routing enablement, then building on top of that will be very difficult in future for after next 2-3 years. That is the whole
Excuse me, sir.
reason
Echo
why
is coming.
we are stressing on segment routing based MPLS.
Your voice has equal.
No, nothing is Cisco proprietary. We are not discussing Cisco today. We are discussing technology. So traffic engineering is different. Traffic engineering can be done in MPLS also. You define a path and that path will take your traffic. But if there is a problem in that path, how you will come to know? How you will know the latency of that path? The traffic engineer doesn't give you that information. With segment routing based traffic engineering, you will get the information that this path has got this latency. There is a type length value field in segment routing which captures the latency of the link and reports back to the controller. So that is why it makes a difference. All your if you think of a 5G deployment, all your 5G deployment is going with segment routing only because they require highly reliable, high latency sensitive networks because it is going for gaming and other applications. Similarly, in future also, if you have some application which are latency sensitive, you can enable that real time. So if you see the journey of MPLS, now MPLS has reached a state where it is being called as segment routing based IP-MPLS. In IP-MPLS there was a dynamic label exchange happening. In segment routing, we are giving labels to a link and a node so that the topology of the network is visible to the controller. So now whatever is being deployed is segment routing based IP-MPLS is being deployed. So that is no, this is not nothing. I told you I'm not discussing Cisco today. We are discussing technology. It's available with multiple vendors. Anyway, Cisco is a leader, so we may have some add-on features that we are not discussing today, but it is available with everyone.
So the entire presentation is created in a way where we are not focusing on Cisco, but amongst the few OEMs which are available in this market, of course, we are one of those leaders who are driving technology. So here and there, some future features we might have initially, and others might catch up in a year's time or not. But segment routing is something which is available with everybody, including Tejas for Make in India. Juniper or Nokia, everybody is there. Yeah, so this is a overview of how, and I think this will just skip here. So now we look at how transformation or migration can be achieved, right? So there are different ways to migrate. Of course, there are multiple different methodologies to do this migration journey. But what is more important is how do we do this migration with minimum impact, minimum downtime, and then how do we transform all services over a period of time and also save the bandwidth and the fiber cores which we have, right? Some of the railways have fiber cores available with them, some don't have it available with them. So depending, there is a variation of the core, and depending on the availability of core, there has been different type of pluggables been taken for the 10G backbone. So 10G backbone with single core, you have a pluggable called as bi-die pluggable, BIDI. So this bi-die pluggable ensures only one core. It splits the trans and receive into two different wavelengths, and then it sends it across the single core of fiber. It is costly, of course, because it has some mechanism to do split and all. It's more costly, and it is operationally a little bit challenging because if one side is BXT, the other side of it is a BXU. So it has to work into opposite pairs, BXT and BXU. So operationally also, it is something which needs precaution and constant monitoring to do that. So again, the fiber core usage can be two fiber core or one fiber core. As we discussed, pluggables will change, cost will change, and complexity will change. Now, how do we migrate? There could be three mechanisms to migrate. One is your TDM equipment migration, which means that I can migrate the entire device in a way. I can start migrating by migrating the links and applications and then observe for a period of time because railways backbone is very critical. I myself travel a lot in trains, so I would never like the backbone to be impacted in any way. So the migration journey by nature can be circuit based migration, box based migration, and then the entire division or zone based migration, right? So there are three classification of migration which can happen over a period of time. So most easiest transformation is the circuit-based migration. So what, from our understanding, what we would suggest is, depending on the fiber core availability, if the core is available, bring up the MPLS boxes in parallel, get the backbone up for the boxes, do a week or 2 weeks testing to see how different things are working. Management testing only. There's no application. Every application is still running on SDH in a parallel way. You cannot rip and replace. Impossible. It has to be a parallel migration, a phased migration. So initially, we bring up the MPLS boxes. Once the MPLS boxes come, the testing is done, the links are maintained. We create a report, 2 weeks testing on that. You first transport the non-emergency applications onto the MPLS. Could be RailNet, could be Wi-Fi, could be CCTV, depending on what I would suggest to start with Ethernet applications, and we'll see how that migration has to happen also. So I'll just quickly put this. Yes. So Sumit, you want to talk about this part? Unmute yourself. Mute. Take this. To unmute again. Echo problem.
Hi. So this is a typical architecture which we think for a railway station, in small station and large station, where you have SDH box today and PDH box, IPPVX, Ethernet. So and we assume that all these stations will be part of the ring connecting to an LSR, and then at the large station we will have an IPPVX and other systems connected on Ethernet and few SDH and PDH application also. So what we are essentially talking that you bring these boxes up, the LERs up. First you create this ring and connect it to the nearest LSR, bring these boxes up and gradually start migrating these services to these LERs. So that is the easiest way of doing, and it will give you more confidence in terms of operating. It's not like that things will not work on MPLS, but since it's a new thing and we are putting it in the network, this has to be thoroughly tested for the application and operation perspective also. So you bring gradually the SDH, Ethernet-based application, then SDH-based E1s and PDH on LERs, run the services for some time, and gradually phase out the SDH equipment. We understand you might be needing SDH for connectivity to agencies like Railtel, where the other end is SDH itself. So you may keep those SDH boxes for some time, but gradually you push them to move to Ethernet and then migrate it. So this is any suggestions on this migration approach which we are trying to discuss. But this is the easiest way, and all brownfield migration is being done like that. Otherwise, if you start removing SDH and putting IPMS boxes, that can bring more complexity and more problems. And what I have seen, I've worked on operations. If things doesn't work when it is needed, the confidence on that technology goes down. So we don't want you to be in that going through that journey. Go slow and steady, and gradually migrate everything.
Anyway, such migration.
We have, as I told you, the only migration which has started is in Delhi Metro Rail Corporation. We are migrating their 50 odd nodes which are on SDS to IPMPLS. They took the same methodology. They tested all the services. They created a ring for 10 nodes. They tested all the services like SCADA, Ethernet, E1s. All the services is now working fine. They will be gradually migrating because we all understand it's very critical. It's not the simple data application running. It's many critical things are running, which is essentially ensured that it is working fine.
So this is just the railways part, but worldwide also, all the major service provider migrations happen in the same way.
Even in telcos also.
In telcos also, they will never rip and
As I
replace.
told you, I came from an operation background. And when we used to migrate the SDH mux to Ethernet, we took the same approach.
Period. So depending on how do we do a project plan for that, so you can look at a window of 4 months to 6 months. where we phase out the entire migration of all the applications to the MPLS. And this time is only because we have to do phased application by application migration. And by the time the skill set, look at what fault, how to analyze the fault, how to look at MPLS faults, the team would also have to be on speed on those things areas. So this journey of 4 to 6 months will help in both the way.
I have a question on the chat that kindly explain the role of LSR in this slide. So LSR, there are two routers usually when we talk about MPLS. One is a P router, another is a P router, and the third category. The third category is an P/P router. So LSR in what we think of in railway, it will act as mostly it is defined as a P router. The provider is a router which will do only switching, but depending the station requirement, we see that it will mostly act as P/P router, where you will be doing a switching from the traffic which is coming from behind, like from the different LERs, and you may be integrating some of the services at the LSR also. Otherwise, you will have to put an additional router to integrate those services, and that will add to cost. You can optimize that by configuring these LSR as P/P router. I hope I answered the question.
One more point. This has been a common question which we are.
Good morning, sir. I have got a question.
Yeah.
Yeah. In the beginning,
when we are taking multiple railways, why LSR? 2 pointers LSR's cost is high. So why can't we use LER as LSR? So LER and LSR, the only differential in between those boxes are LER is lean and mean. It's a 1 RU box. It has defined 24 1G ports, one slot to accommodate either E1, STM1 or any of those cards, right? So a very lean and mean box, a very low cost box, which also means that the memory capability and the route capability of the box is also very small. When you go to LSR, the main differentiation is it is a higher end box on the capability of its route holding. The number of routes it can hold is pretty very high in number of lakhs of routes it can hold. And V6, V4, MPLS routes, BGP routes, it will have a table for all these kind of route handling capability. Now, when you introduce multiple kind of route handling capability in a router, you want to ensure that one of those routing protocol failures should not impact any other routing protocol failure. So what we do is in a LSR kind of a router, we make independent memory process for each routing application. BGP runs in a process. OSPF runs in a different process. ISIS runs in a different process. And each failure of one of the process will not impact the other process. This memory separation of the process is very critical in a LSR kind of a LSR aggregates all your control communication traffic, all your CCTV traffic, right? So the number of routes and subnets which land up in an LSR is much higher. LSR sitting at a junction might also interconnect to a rail kind of environment or to any other kind of interconnect which you want to do in the future. And that is why you have a separation. Now, because of these processes being separated, these number of routes coming into one box, LSR is a box which has route processor redundancy. So all we talked about, the number of routes, which is route information base, RIB, and number of processes that are running, that in the router it runs on a route processor. So what we have done at LSR, we have also given route processor redundancy. So that by chance if a route processor also fails, nothing will happen. That is the kind of impact LSRs are has. And that is why LSRs have different mechanisms on their controllability, and that is why segregation of the LER and LSR routers are there. Just wanted to. A lot of questions keep coming across LER and LSR.
So there is another question that difference between LSR and LER. I think Binu explained. The person on WebEx might not be able to hear him thoroughly. So LSR is a bigger router with all functionality. LER is a smaller router with limited scale capability and with all functionality. LSR and LER technically supports all the features. And LSR is usually a label switch router which does switching. You can insert services also. LER is a small router with usually a single RU router with all those features which are available in LSR but with a lower scale. The second question.
Couple of questions. Both LER and MPLS routers and SDH routers, both during the migration journey will work on separate cores of fiber. So during this time, there will be two networks running in parallel for a period of 6 months or 8 months, or how much time you want to understand and take the journey, right? Depends on the individual railway themselves. So there has been some questions on this. So both will run in parallel. The same way SDH is connecting onto the fiber, in very similar manner, LER and LSR will connect on the fiber. Traffic will come and aggregate onto the same core of fiber on which MPLS is connected. So LER, LSR, they are on the same core. They are not on different cores of fiber.
So there are questions. I think we can take questions at the end. Yeah. So now we'll talk, since we are building a network, so we have to talk about the convergence of the network. The SDH by default gives you 50 millisecond convergence. We can achieve the similar convergence in IP/MPLS also, sub 50 millisecond. So there are three kind of convergence which we usually define in three kind of convergence which we will usually talk in any network. One is the link convergence, another is the node convergence, and third one is the services convergence. So we will discuss all the three convergence, and for link and node convergence, we can get sub 50 millisecond convergence. Sub services convergence may go to 100 or 150 millisecond because its whole services has to migrate to a new thing. So first we will talk about the link convergence. What is the link convergence? Suppose in between, just for example, station R2 and station R3 are connected, and all the traffic is going via direct link from station R2 to R3. In case of failure of station R2 to R3, the traffic has to go via some other link, that is going via some other station. So that is this link is called a protected link. Whenever this link fails, the router detects that link has been failed, and it automatically there's a backup path created, and it switches the traffic back to through the backup path to R3. There can be a router in between. There may not be a router in between. It can be directly connected also via some other medium. So R2, R3 can be connected via a third path using a router in between, or R2, R3 can be connected directly via a third path without any router in between. In both the cases, the 50 millisecond convergence will be required, will be achieved, and there are a few protocols which we need to enable on day one on those links. One is BFD, bidirectional failure detection. When a network will converge, unless until it detects a failure, it will not converge. So to detect faster failure, we have to enable a protocol which is called BFD, bidirectional failure detection. What it does, it sends a echo message on the link, and every 3.3 millisecond it sends an echo message. So essentially if 3 echo messages are missed, which is 10 millisecond, it will declare the link down, and as soon as it declares the link down, the backup path is triggered. So usually the link convergence happens within 20 to 30 milliseconds, which is much less than 50 milliseconds. So this is the BFD is one of the protocol which we need to run. Apart from that, there are convergence protocol which is IPFRR, TILFA, or MPLS FRR has to be enabled on the router. This is a one-time job. It is not being done for everything. You have to configure. It's a single command that you have to configure in the router one time when the router is setting up, and this will automatically dynamically calculate the backup path, and traffic convergence will happen within sub 50 milliseconds. Any questions on this? Automatically, all services will be. Yes, you can define a failure, a revertive, non-revertive as you do in SDH. It is depending upon the IGP. IGP is the cost of the link. Once the lower cost link is always preferred. Once the link is restored, it will automatically switch to the lower. Pardon? That is what I'm saying. The day one when you put up a router, you will define this. Not you don't have to define on day two. When I'm configuring this, I will have a template. I will define everything.
So unlike SDH, the world of MPLS will also need a designing to be done, right? So you will have to engage design services, either OEM or SI or whoever is bidding or winning. They have to do a complete design of the network. Design of the network will bring all these protocols to be used. Which protocol for what protection, which protocol for what service. Like PRS is running OSPF. So how do we carry OSPF over your backbone BGP network or segment routing, right? So all these are part of your design. So as you said, everything can be enabled, but somebody has to design how will that become effective. So that is one important thing in your journey. You will have to engage with system integrators.
So that is what you are doing today also. When you are deploying SDH network also, you define a trail, you define a protection path, you define some protection mechanism, everything you do on day one when you are defining a circuit, right? The only difference is that you are defining per service, like you are configuring E1, you are defining a protection path, or STM1, you are defining a protection path. In IP, I'm doing at the backbone level itself. If fiber cuts, all the services will be automatically rerouted. I don't have to define it per service wise.
What will be the switching time?
Sub 50 millisecond.
Uh, uh, can it be reduced to 10 milliseconds?
No, it can't be, because you have to detect first. No other technology that none of the technology is committing sub 10 millisecond. The standard is sub 50.
Answer the questions. You go on this slide, otherwise you'll keep answering the question. Let me answer it, you go on it.
Okay. So the second protection is the node protection. Suppose a node fails. Suppose I have to protect the node R3. Request to everyone to be on mute, please, because I'm wearing a headphone, and while speaking, something comes into the ear, then it's become very difficult to speak. Put your questions on the chat. Binu is answering. Just a humble request, please. So now I have to protect node R3. Suppose this is a node which I have to protect. When I deploy IP MPLS with segment routing or IPFRR, I dynamically calculate a path which calculates all the possible paths to reach. So where traffic has to go to R2 to R4, it will dynamically calculate all the possible paths and keep in its database that what all paths are available for me to go to R2 to R4. And in case of any link or node failure, it will automatically switch. And since it is predefined, pre-calculated paths are available, that's why the switching time is less than sub 50 millisecond. Otherwise, it will be much higher. So that is why we are stressing more on segment routing based IPM failures. Because in case of a node failure, also if you want a sub 50 millisecond convergence, that can be achieved using segment routing. The third and important thing is the services. It's not coming on. Coming. Service convergence. So there are two protocols which you define when you run an IP/MPLS network. One is an IGP, which is OSPF, as you know, OSPF or something similar protocol. The other protocol is BGP, which is used to carry the LAN segments back to in your. You have to populate all the routes from node A to node B, node A to node C, so that the traffic can flow. So there are two protocols. When we define BGP for carrying the LAN segment route, because the traffic is coming on LAN and going to other LAN, we define a process which is called prefix independent convergence. This reduces the convergence time to say sub 100 millisecond. In case there are two scenarios. Let me explain there. So there are two scenarios. A C is connected to two different P, which is a very common scenario. One important node
is the
LER. LER, or it's a PRS system, you can say. It's a PRS system or any system connected to two different LERs. And if this P1 is the LER1 is the primary link, LER2 is the secondary link. A link to LER1 fails, you want the services to go through LER2, and the convergence would also be minimum. So this is called edge protection. We can define edge protection where if the link from one C1 to LER1 is going down, it shifts to LER2 within 100 or 150 milliseconds. The second protection is called, or is LER1 has completely gone down. either the link has gone down or LER1 has gone down, it will switch to the LER2 within 100 to 150 milliseconds. The second protection is that suppose in between this is edge protection because I'm protecting the edge using for the service convergence piece. The second protection is the core protection. Suppose I'm connecting to some LSR or LER and that core uplink has gone down. It becomes isolated. So how to switch to other core nodes? That is called as core protection. So there are two kind of protection available: edge protection and core protection. So there are three protections we discussed. One is the link protection, failure of link. The second protection is the node protection. The third protection is C to P link failure, and the fourth protection is how the services will converge in case of some bigger node is failing. So essentially, we define all these kind of protection in IP MPLS. I hope I have covered the services and the link part. Any questions? Otherwise, we'll move forward. We are running out of time. The other important factor when you move to a packet network is the quality of service. As Binu told in the beginning that there are toss bits in IP header, and there are 3 toss bits. Essentially, you can have 8 class of service. So you can define different classes of service: voice, video, other applications. So let's compare with the SDH era. You have a voice application running on SDH. You defined a 2 Mbps pipe. Whether the voice is running or not running, the 2 Mbps is reserved for that voice, and no one can utilize that. And your STM1 mux is a STM1 mux only. You cannot take more traffic than STM1. Even your actual utilization is a DSP. When we talk about a Ethernet-based system like a packet system, the first advantage is the stat gain. What is the stat gain? I have a 10 Gbps uplink. At the edge, I can provision 20 Gbps because not everyone is utilizing at the same time. But how to guarantee with the stat gain, how to guarantee quality of service when a critical traffic is coming? That is being achieved by quality of service defined in the packet network. What we do, we defined a hierarchical quality of service in which I create a parent policy and child policies. Now, suppose I have a voice application, I have a video application, I have an internet application. I want to give maximum priority to voice application. For that, I will define a low latency queuing. And the low latency queuing means if I have defined, suppose 500 megabits per voice application, and if the voice traffic is coming, it will always get that 500 megabits. Sorry. Suppose I have, then comes the class-based weighted fair queue. In that, I defined a minimum bandwidth, that is a CIR, which is a committed information rate. Suppose I defined 500 meg for a video application also. Then comes the standard class where internet is working. Again, I defined 500 meg for that standard class. Now, suppose voice and video is not utilizing the bandwidth. And this standard is the internet, so it requires 1 Gbps or more than 500 meg. So if those classes are not utilizing those bandwidth, this can shoot up to 1 Gbps. And the moment the voice and video traffic kicks in, it will reduce back to 500. So this gives you much more flexibility in terms of bandwidth adjustment. So
लेकिन मुझे लगता है होना चाहिए.
Can you request please to go on mute?
ये तो कंट्रोल कर लेते हैं. ये सर वो कंट्रोल कर. सर मुझे ज्यादा.
Go ahead.
So someone speaks in here, it's very difficult to speak.
So many people are very difficult to.
So we can define, depending upon the services, we can define the queuing methodology. Other important thing is random early detection. What is random early detection? I'm just touching on the quality of service part because it will become very, very important for you. So random early detection is something that the traffic, suppose you have given a 1 gig pipe to someone and that 1 gig pipe is full. So there are two kinds of packet drop happens. One is tail drop, otherwise is weighted random early detection. So if you start doing a tail drop, your applications may start suffering. So what it does a weighted random early detection based drop, which means high priority traffic will be dropped less, low priority traffic will be dropped more in case of a congestion. So that also gives you flexibility to run different application on packet based network. Okay. So I think this slide we have already covered that what all services are running and what are the last mile.
So we are moving to a next slide where we have categorized the services into different kind of MPLS flavors. So if you talk about PRS, UTS, VoIP, Office LAN, FYS, RailNet, all these are basically end devices is an IP speaking device. It's an IP device. So it will come under a layer 3 VPN. In layer 3 VPN, you can have different kind of flavors like hub and spoke, mesh or extend. We will cover that. In case of data logger, SCADA or analog system, which is on E1 or Ethernet, where the layer 2 frames are going, it will come under layer 2 VPN. We can have Ethernet over MPLS or circuit emulation over packet switching network. Then we can have multicast, which is CCTV or any other video application running multicast. So basically, we will be running three kind of services, three different flavors of MPLS to accommodate all your 10-15 services. So it becomes easy to manage because you are running only three kind of three variation in your boxes, right? So what is a hub and spoke VPN? When I say hub and spoke VPN means, suppose let's take an example of a PRS system. PRS have a zonal router in each zone and they talk to Delhi and or Bangalore. I'm not sure. Delhi is one I know, other it may be Bangalore. The zonal router talks to Bangalore and you have edge systems sitting in at or the station where booking is happening. So all the stations will become a spoke. Essentially, these stations have to talk to the zonal router only. They don't need to talk to each other. So they are defined as a spoke. The zonal router is defined as hub. So all the traffic from each station has to go to hub only, not to different stations. So they have been configured to talk to spoke is configured to talk to the zone only, which is defined as hub. This is hub and spoke, where each spoke stations are not talking to each other, and that is controlled by the MPLS configuration. The second is mesh. Suppose you have a application which requires everyone talking to everyone on an IP application. So the difference is that here everyone is talking to everyone, and there is no hub concept is not there. So this is called mesh VPN. The third one is an extranet VPN. What is an extranet VPN? Suppose there is third party service like RailNet is giving internet, and there are multiple departments who want to take that internet. So what I will do, I will configure a RailNet VPN, and in that RailNet VPN, I will allow all the different departments to talk to this RailNet VPN. So although these departments are not talking to each other, but they are talking to a common VPN, which is a RailNet VPN for internet services. So this configuration is known as extranet configuration, and RailNet VPN is an extranet VPN which is talking to multiple different departments. So this flexibility you will also get in this when you define the services. Now coming to L2 MPLS VPN, there are two kind of L2 MPLS VPN. When we say L2 MPLS VPN and L3 MPLS VPN, L2 means the way you are doing things in SDH, that any frame is coming, I'm putting a wrapper of SDH and transporting it to next destination. Similarly, in MPLS also you can do any traffic coming, you put a wrapper of MPLS and transport to other destination. So there can be two inputs. One can be an Ethernet based input, the other can be a E1 based input or a PDH based input. To run these services, there are two kind of configuration: Ethernet over MPLS or circuit emulation over MPLS. Why it is circuit emulation? Because essentially the pattern is circuit based, circuit switching. I am carrying it over a packet, so I'm emulating a circuit over a packet network. So that is why it's called a circuit over MPLS on a packet switch network. So this is an Ethernet over MPLS where you have a core backbone where your IPLS network is defined. A Ethernet circuit is coming to connecting to any LER, and LER is creating a pseudo wire. Pseudo wire means I'm creating a wire which is pseudo in nature and traversing all the nodes. All the nodes coming in between will not have any visibility of what is going inside, and it will drop to another node where the end destination is connected. So that is why it is called a pseudo wire. And the last mile which is being connected is called an attachment circuit because I'm attaching a circuit and that is being carried over a pseudo wire. I hope I'm not going fast. It's fine. So this is pretty important, and you will have more and more use cases of this SESO PSN over, which is TDM over IP. Essentially, you have E1s coming to a MUX, then a SDH network, and E1 is delivered. Now this MUX, this transport piece is replaced by a packet switching network. So just take an example of BTS or anything. The even is coming to a LER router. From LER, I'm creating another pseudo-var, but this time it's a circuit pseudo-var. So it is called SOPSN or pseudo-var E3 as a standard. So it's a TDM pseudo-var which is starting from one point, again handed over to another router, and again E1 is being given back to the end device.
Repeat the pseudo-var. Repeat pseudo-var.
Pseudo-var is a circuit which is used to carry non-IP traffic like frames. In SDH, when you create a trail, what you do? You create a trail with, and behind the trail there can be IP packet or anything. You put a wrapper on top of that packet and transport on SDH. When we create a pseudo-var, I get a Ethernet frame or a E1 frame. I put a wrapper of MPLS packet and transport it. And when I'm handing it over, I'm removing that wrapper and handing over the traffic back to the end device where E1 is required. I hope it's clear.
And there is some circuits which will need station to station drop.
That is again a pseudo-var. So there can be two kind of traffics. Like suppose I am running an RS-232 kind of application, what I have seen in metros. They are point to multi-point in nature, and they require hopping, station hopping, right? So there we can also create a pseudo-var, or we tell them as a raw circuit. What the raw circuit defines? It defines the hub site as a master. The rest all sites are a slave, and there's the IP defined in the all slaves starts talking to the master site. So that is from station 1 to station 4, or I can create pseudo-var from station 1 to station 2. There is no limitation in that.
But depending on how your application works, so if you block signaling or your data logger, if it's connecting to every station, then the event will be created in such a way that it will be a VPLS kind of a network on back of MPLS, and it will be getting that particular one event for data logger will be adding and getting dropped at every station. So it is basically defined by the application, how the application wants to define. If an application has an event as a requirement from station directly to the divisional headquarters, then the event will be created from the LER directly to the LSR at the junction location. So defining how application wants to behave. A control communication right now, native, not VoIP based control. Native control communication is a bus architecture. It's a linear. So every stage the phone is always on, control phone is on, and the section sitting in a division headquarter is talking to every time. So when we emulate this traffic onto MPLS, create an even for this till it does not come to Ethernet. We will create an even on this, and we will create a VPLS kind of a network where it is dropped at every station. Right. So it depends how application is behaving. The same way circuits can be created.
So what happened here? So coming on the WebEx now?
No, it's coming on. Hey, WebEx.
Okay. So this is just explanation how this even circuit is being transported. A raw TDM T1 even circuit is coming to the router, the first router. Then the router puts a header on top of it, the wrapping on top of it, the MPLS header on top of it. Based on the MPLS header, the in-between router like LSRs or the other LERs will just do a switching. They will not open the packet and look what is beneath the packet, because the packet is not destined for them. They will just do a switching of the packet, and the packet is being sent to another end where the wrapper is removed and the packet is being delivered. So it can be Ethernet packet, it can be E1 packet, it can be a sub-E1 packet, it can be a PDH packet. Anything, it is irrespective. As it is being done in SDH, the same thing is being done in MPLS also. The only thing is change is that the wrapper has been changed, and the wrapper was an SDH wrapper, and now the wrapper is an MPLS packet wrapper. Want to take this or?
So now we are looking at the kind of services. So we have talked about multiple different services, native services. We're classifying this into two services. Native services, which is essential for the control communication signaling of railways to work. and then non-native services like PRS, voice, RailNet, which are running on top of this backbone. Now, there has been in our multiple discussions, there has been discussions on how this connectivity will be worked. Do we need a PRS router or not? Can I remove a PRS router out? Because it's again investment at both sides, right? It is going from one single pocket. So there are pros and cons for both solutions, depending on each zone, how the zone is connecting. So what we are connections from all stations come to one central router. From there, it is handed over to the CRIS router, and that's how it works. So ideally, it can work directly over a Ethernet VLAN. From the switch can come into the MPLS router, and we can create segmentation of PRS, VRF. It's okay, sir. So PRS, VRF segmentation can be done, and traffic can be given, and this traffic can all PRS traffic from all the way stations in the zone can come over to a single router as defined in the same VRF, and from here we can hand it over OSPF to CRIS router. Now it depends on multiple different things on how flexible the railways is in changing the protocols, changing the IP subnet. Do you want to use a different protocol there? Do you have the flexibility to do different protocol? When you hand it off to the CRIS, how will you hand off the traffic? Will it be a OSPF LSA or would it be a different BGP route? So these flexibilities will define how we can go ahead. Ideally, technically it works without an PRS router, but ideally from management point of view and administration point of view, if a router sits in the PRS, it will be more effective because that is a completely different OSPF boundary which is working. So you just simply disconnect the events which is currently going to Railtel or BSNL, connect the Ethernet or optical Ethernet WAN port in the router directly to the MPLS router, create an VRF, and the OSPF is running pre-configured in there, and rest there is no other integration you need to do, right? So, and this will give an admin facility for anybody in CRIS wanting to log in to the router. You can enable the login. If there is another service provider redundancy which is required, that also can be required. So there are multiple scenarios.
I'll just add one thing. If you recall the slides on the services which Binu showed in the beginning, when you have L3 switch and you are connecting on the Ethernet back to L3 switch, why? Just to limit the broadcast coming to a router. The same logic applies here also. So you need to limit, you need to have a demarcation between the CPE and the PE. That's why you need a service router, because you don't want to put multiple router for that demarcation. One for PRS, one for RailNet, one for this. So you can have a router which can accommodate all the services and take one Ethernet with multiple logical separation onto MPLS. So the logic is same. Like in L3 switch, you put an L3 switch for the services, put an L3 router in for this different services, which is given by a service provider like RailTel, RailNet, or PRS by CRIS. So there's a demarcation on the CP and PE front.
No, yes, sir, sorry. Not needed, sir. Not needed. At base station also, yeah. So base station also it will learn. Base station router also, LER router also, segmentation of VRF can be done. Base station also, segmentation of VRF can be done. No, sir, so segmentation, what you're calling now, so there are two benefits. Instead of deploying a router for PRS, UTS, voice separately, what we are calling out is have one service router for non-native services. So one is your native services, which is signaling your running of your operations, which is very critical. So we segregated that out. Now we have a non-native services which is running, like PRS, voice, RailNet is also one of this. So instead of buying a router for each of these applications, have a service router where all this traffic will come into play, and the service router will have a L3 peering with your MPLS LER, and the segmentation will be maintained. We can do it without a router also. So there is no challenge in technology. The challenge is only come in admin point of view. If there is some change in RailNet you want to do, For example, railnet subnet change or some classification you want to do, IP change of railnet server and all, you will need to log into your MPLS core backbone router and do changes there. Now this is your backbone. So usually you can do every changes, nothing would happen, but human errors are always possible in such a scenario. So intent is to always ensure that the least change has to be done in the backbone router. That is why we want to segment the services out and just use the backbone for carrying the core traffic.
Security is also one reason. You don't trust the thing you're not managing. How can you trust those things? You need a demarcation point.
So there are multiple mechanisms to provide redundancy for these service routers also. So the service router will be on a one leg connected to the MPLS router. The service router can have events from Railtel coming into it and directly connecting to another LER or LSR and create a path redundancy for this application. So something goes wrong with the base station LER or something goes back wrong with the link cable, all kind of those failures can be accommodated. So that service router gives you the ability. Otherwise, you now need to bring all these redundant paths into your backbone router, which also is possible, but the lesser interference there, the more stable the network is. Yeah, the same thing, different scenarios we have explained. In this scenario, you see the redundancy is given by the LER. Instead of service router, the redundancy using events are generated from the LER itself. So there are multiple mechanisms because LER also has even ports. You can also create a LER level redundancy also using events or STM1.
Why this came into picture? Because I understand that your PRS has got even redundancy across stations, and there was a requirement that how I can build one redundancy. So if that is required, that can be done.
Yeah, so these are all different mechanisms. Looking at migration procedure, this is something which we discussed, right, in the initial. So you on the left part, you have your SDH and your native PDMux working. Okay, so the way the migration can come is in phase-wise migration. Your the backbone and LSR will migrate in the first phase. So you will have a parallel network running running for 6 to 8 months. And while the parallel network is running, you migrate your Ethernet services. First, you migrate some few VLANs into the Ethernet router, and phase by testing, you migrate your events and your signaling. And then slowly over a period of time, you take SDH out and only have MPLS backbone. So you get your 2 cores of fiber back, which you were struggling for in the meantime, right? So our always suggestion is don't go much for BiDi pluggables because they are very costly and they are complex to manage. So if you can have 2 cores for this interim period of a year, 6 months, you should leverage those 2 cores to create the backbone network. These are some migrating scenarios which we created just to get a fair understanding from you on how we can migrate station to station. And this depends on which kind of application also. Like here we have shown a even directly generating coming from a station getting dropped at the division headquarters. There could be even which is mapping dropping at every station and then going to division headquarters. So there again different ways the migration journey can go on, right? So I will take a pause at this point and I will request if there are some questions from the team. As per RDSO specific introduction of MPLS notice station, route redundancy function no longer be required to be provided to these IP routers as that will the job will be to MPLS node station. Yes, so RDSO definitely refers to route redundancy as part of MPLS fabric. But having MPLS means you are having a single router and routers can be susceptible to failure due to power fluctuations or due to any kind of dust or any implications which goes on. So that is why we say that redundancy needs to be created if required for certain applications outside the core network also, and this is an option. So intent is to just
थोड़ा हिंदी में भी बोल दिया करो सर, थोड़ा हमारी समझ में आ जाएगा थोड़ा बहुत.
हिंदी में भी बोलूं हाँ, हिंदी में ज़रूर बोलूँगा सर, मातृभाषा है। तो मैं
Sir, English please, sir.
सर आप लोग डिसाइड कर लिए, नहीं आप लोग डिसाइड कर लीजिए इंग्लिश में बोलना है कि हिंदी में बोलना है।
ठीक है, इंग्लिश ही बोल दो, हम तो ठीक है चुपचाप बैठे रहेंगे, कोई बात नहीं। इन
नहीं
लोगों
तो
की समझ नहीं ठीक, कोई बात नहीं।
नो सो
क्या करें,
लेट देयर नॉट बी
अब एक आदमी के पीछे सब लोग डिस्टर्ब हो, कोई दिक्कत नहीं।
let there not be difference. I will explain in both languages. So what I was saying is redundancy in the core is always there. In railways network, the MPLS backbone will have redundant routes on the backend side. But at the station side, the LER is still susceptible to a failure due to multiple different reasons. Could be power, could be dust, could be multiple different reasons. So that is why we said some of the services which are critical, if you want to give them a redundancy from the link node point of view, you can have an external redundancy plan. These are all different mechanisms to adopt. It, at the end of the day, railway is the person which decides how to do and what are the critical things to do. अब इसको हिंदी में बोल देता हूँ, MPLS बैकबोन में सारे जो रूट्स हैं वो उसके सारे प्रोटेक्शन उसके सारे क्रिएटेड है ऑलरेडी, मतलब सारा प्रोटेक्शन उसमें है बैकबोन रिडंडेंसी के। लेकिन स्टेशन पे एक ही राउटर है, जिसका मतलब है कि वो राउटर फेल हो मतलब वो राउटर खराब हो सकता है ड्यू टू पावर फ्लक्चुएशन या डस्ट की वजह से। तो अगर कुछ क्रिटिकल एप्लीकेशंस हैं आपके राउट स्टेशन पे जिसको प्रोटेक्ट करना है आपको, तो उसको एक सर्विस राउटर या तो LER पे E1 को यूज करके प्रोटेक्शन किया जा सकता है। ये सारे अलग अलग मैकेनिज्म्स हैं, ये आपके ऊपर डिपेंड करता है कि आप कौन से मैकेनिज्म को अडॉप्ट करके कैसे आप इसको प्रोटेक्ट करना चाहेंगे।
Just to add what Binu is saying, there are many regions where we are working. They don't have resiliency in terms of rings also. They can't create rings due to unavailability of fiber. So we have to keep all options open. हम बहुत जगह ऐसे जहाँ पे काम कर रहे हैं जहाँ पे रिंग बनाने की भी सुविधा उपलब्ध नहीं है, तो हमने सारे विकल्प खुले रखे हैं। आपके पास सारे विकल्प हैं, आप जिस विकल्प पे जाना चाहेंगे वो विकल्प आपके पास अवेलेबल है।
Correct. So, for example, the Mumbai division, because I've worked with them, so I understand their architecture. It's kind of a linear flow across Mumbai division. Now, to give a path diversity protection is based on path diversity also. You can create a secondary link of 10 Gbps on the same path, but which will mean that अगर वो path cut हुआ, fiber cut हुआ, तो दोनों कटेंगे. So how do I protect using central railway? So which means Mumbai division at the two legs where it's interconnecting to central railway would need a STM if your central railway is on STM, or if central railway is also migrated to Ethernet, it's simple. You have a 10G path connecting and we can create a boundary there and we'll have a boundary router configuration and a protect path will be created via central railway. So this is the beauty of Indian Railways. So there are so many interconnection available for railways. It's how do we implement and how to take advantage of it. So if both zones are on Ethernet is the most simplest thing. If one zone is migrating to MPLS, the other zone is still on the native SDH. At the two border junctions, you will need a STM ports on the MPLS router to create the interconnectivity. And we can back up the traffic using that.
So we are also not adding more complexity. We have kept a scenario that you have a fiber here, you have a fiber here. In between one no fiber, you have to transport over SDS. So everything is possible. The only point is that MPLS is flexible to whatever architecture you want to define. आपके पास किसी भी तरह का आर्किटेक्चर को डिप्लॉय करने की सुविधा यहाँ उपलब्ध है। आप कहीं से कुछ भी कनेक्ट करो, थोड़ा डिफाइंड वे में करो, प्लान करके करो, आप कनेक्ट कर सकते हो।
One more question which I have written. So emergency communication is again a 4-wire communication which is running in parallel to your railways network or copper cables, right? So each station, wherever these comes in, the copper cable comes into the station, we can have a FXO or FXS card in a voice gateway router, a small voice gateway router as part of, and this is covered in VoIP based train control communication. In the RDSO draft, this is very clearly covered. But as the question is asked, there's a voice gateway which will come into the station. The 4-wire communication of the copper cable will come into the voice gateway. Voice gateway will convert this TDM into IP and will connect it back to your main control communication of section controller and station which is going on. And this can be divided. There could be multiple ways you can do define it. Uh,
What are the power supply options for these LSR LERs?
If you see railway network, a ring like this, largest will become LSR, then LER ring, then again LSR.
So depending on how the railways is, but we'll use the same fiber. Could be a single core or could be dual core, based on what kind of core connectivity the particular division or zone uses. But it will be the same two cores or same one core which will connect LER and LSR. So that will save.
The only point when you require another fiber pair, when you want to create high capacity between LSRs.
Yeah, that is a backbone network. So one question on WebEx just before coming there. So all the LER and LSR routers can support DC power supplies, though all the boxes, all OEMs have got DC, and all the boxes which we talk about LER, LSRs are temperature hardened boxes, which means they can handle up to 65 degrees of operation. Sorry, sir, the question.
They will need a rack for that for sure. You cannot mount it.
Telecom has got rack.
Okay.
This is the typical waste the bill of material essentially counted. All reasonable elements.
So depending on station to station, but from our understanding, you will need a LER router. LER router, I can show you what is a kind of router. I think we have covered in somewhere here. कहीं पे इसका एक फोटो था शायद. Yeah. So, yeah, it will, Southwestern Railway is one example, but ideally this is the kind of a router which we'll see in the way station. This is LER. LER will be a single 1 RU. It will have 24 1 gig ports. RDSO asks for 8 1 gig ports and 2 10 gig or 4 10 gig combination. So it has 4 10 gig ports. Is at 24 1G ports, optical ports, and it has got one slot. This slot can take from 8 to 48, different kind of 8 port even, 16 port even, 32 port even, 48 port even. Ideally in a way station, 8 port even will be more than required looking at the kind of application. But if some way station needs more than 8, then they can go for 16 port even card. This slot also can take STM1 or STM4 port also. But there's only one slot. So that is why the LER is lean and mean in the cost and in physical structure, right? LSR is a different name. LSR, sir, cost. SW.
Open in SWR, you can find out.
Yeah, SWR cost is there. LSRs are slightly bigger routers, so they will have multiple slots. Usually, what we give across is 6 slots, and each slot can handle 8 10 Gbps or STMs or evens or Ethernet port. So there was one question also in the chat whether I can at the LSR junction can I use LER and LSR combined in one router? Technically, if you ask a technocrat, yes, depending the number of events required at the LSR location, because you are converging now the LER application also into LSR, you can take the number of events into LSR, and you can, instead of having a LER and LSR, you can have a single box which can do both the functions. But RDSO says differently, so it depends on railways what call to be taken.
So with our experience, we have seen the requirement of STM1s in LSR to connect to Railtel, and that is not part of RDSO. So it all depends from this zone to zone, division to division, what they want.
Can we use the bandwidth is dynamically changes in the router, whether it is configurable or whether it is dynamically it will change bandwidth?
You have a 10 gig pipe, it will always give you a 10 gig bandwidth. I explained in the QS that for different applications, you can define different bandwidth. Right.
So that is at the time of configuration, but if the bandwidth increases, the circuit needs more bandwidth.
So if the 10 gig port can give you only 10 gig output.
That is okay. In that one of the circuit, it requires more bandwidth for time being.
So that is bandwidth on demand. For that you need automation.
Automation
is possible. Cost is one thing, and if you are single fiber, then you would require a similar kind of interface at both ends.
Okay, but what about the speed?
Speed is same. Speed is same. Both are 10 Gbps. both the ports are 10 Gbps, and BiDia can in 10 Gbps till 40 kilometers is supported. So if you go for a single core fiber and you're taking a 10 Gbps speed of the pluggables, 10 Gbps performance will be there and the kilometer can go.
If the LER will be able to replace all the routers which are available at the base stations.
Yes, LER should be able to replace all the networks which are available at the base station.
Because presently we are using a lot of routers for different services.
Nothing in major. Nothing in major. Only yes. Existing DC power supply can be
But
used.
64 kV cells can we drop straight away?
No. So
Will
even
this
you
have
can
a
drop
redundant
straight
power
away.
supply?
64 what you want to drop? ENM, RS232, those can be dropped. But on channelized even, you want to 64 or you want this SCADA 64 kV?
Channelized.
These LERs are having redundant power supply.
USB for what? Can't put data on USB router.
No. The security.
Any router will be available to.
Security threat is there. No, sir.
Whether layer need to be 1+1 mode, two router needed in one station, or single router is enough for
Some questions for the WebEx. LER power supply is DC. Redundant field replaceable power supplies are there in all routers. Field replaceable means once one faulty, another is working. You can just pull it out and put a new one without interrupting the operations of the router. Second question was 2 LERs being required, not required. IP/MPLS does not need dual routers unless you have different fibers you want to run for the fiber protection as well as the link protection. Then only dual LER will make any sense in the play. But if the fiber is same, then same LER will work. And these LERs are like very resilient in nature. So the failure rates of these LERs are very minuscule from what we have seen. These are deployed in lakhs and lakhs in geo networks and also.
Coming to your question, why USB is not supported? USB you usually put in a system which is consuming the data. Router is not consuming it. Router is that's why USB.
So there is another question of acceptable loss on the OFC cable. So it depends on multiple factors. The loss is calculated. You have some depending on fiber loss. Depending on the length of the cable, depending on the type of the cable, on number of splice that cable has, and the number of end connectors the cable. There is a formula is there which is globally used all across. So that can be calculated.
So
what is the major difference between LER and LSR
10
router?
kilometers it will be different, for 40 kilometers it will be different. Coming back to this acceptability of loss, a router is either a DTE or DCE device, right? It will sense the data depending upon the signal strength. If the losses are more, even if I put a 40-kilometer SFP, it will work for 20 kilometers wise. So router doesn't add or delete anything from the fiber loss. Theoretically 80 kilometers, it all depends upon your fiber quality.
यहाँ पे लूप हो जा रहा है voice.
-36 dB receive power.
Can MPLS LER? So these receive power and sensitivity of RS, RX are available on the data sheet. They are common for all the OEMs. The pluggables are available on public data sheets. I don't remember exactly what, but -36 dB definitely is not supported. There is a very high loss parameter for this.
How many kilometers?
Depending on the kilometer also. So the other question is LSR and LER, what is the difference? So LSR is a high-end router. It will aggregate more routes. It is usually put at division location, junction location. Junction location will get all the subnets of CCTV, voice, all different app rail nets, all coming into this one single router. That is why it's a high-end router. It has more route handling capability. because of more route handling capability, it has process redundancy, processor redundancy, and stuff inside that. LER is a mean and lean and mean router. It has inbuilt processor inside it, and there is no processor redundancy in LER, which is not required because only base station routes will come into it, which is very less amount of routes which will come into LER router.
LSR and LER share the same features. So you can run all the services for LSR or LER.
Yes.
No difference in feature set.
Feature set
There's
is no
scale,
difference.
interfaces, redundancy, that's it.
Correct. Yeah. So any more questions on the WebEx?
One more question. Can we take
Protection from private stations? If yes, then how service can be programmed?
You can do that, but that has to be carefully designed because it all depends how much bandwidth you are pushing from that station. Because you are creating a ring for multiple stations, and if one leg is 100 Mbps, the whole ring capacity becomes 100 Mbps. So that
No, he's asking.
that is a protection.
He's asking different service provider. He takes a link at the terminal station. The station does not have a ring. It's a spur station. And can he take a second service provider to provide redundancy for failure?
What kind of link are we getting?
Anything. So he's asking, can we take a 100 Mbps link?
You
Any
can do
link.
that. You can do that, but that has to be carefully designed. What all services are running and where it is getting connected, and what all traffic will come in worst case scenarios.
So it's always it needs to be engineered. Of course, anything and everything is possible in the world of MPLS and the world of Ethernet. But the way the design is done to ensure we recover from any failure the fastest possible mechanism, right? So it is possible that you can program it.
We have to work on a design which is fundamentally keep it simple and straight. That is the fundamental of any design. The more you put complexity, the more it becomes difficult to manage.
So any more questions on the WebEx?
सर कॉपर केबल का इसका रोल क्या रहेगा सर कॉपर केबल का रोल फ्यूचर में
कॉपर केबल का रोल ज्यादा कुछ रहेगा नहीं सर फ्यूचर में.
जैसा इमरजेंसी कम्युनिकेशन के लिए
इमरजेंसी कम्युनिकेशन फिर भी क्वाड पे ही रहेगा. इमरजेंसी कम्युनिकेशन के अलावा कुछ मेजर रोल कॉपर का नहीं रहेगा रेलवेज में. क्वाड केबल पूछ रहा है, इट्स डिफरेंट कॉपर.
Sir, what about those circuits which is working on 64 kbps? Like
So 64 kbps circuits can still continue to use your PD mux, convert them, merge them into a even, and then the even can come into a channelized even can come into the LER router.
that means we will have to provide continue PD mux at every wayside station.
Yes, unfortunately, yes. But please bring out the kind of interfaces that the application is using. We can see some of the major sub 64 kbps interfaces are also available in router, but then the router size and type will change wherever you need more sub events, and also the cost. So if you look at the cost efficient mechanism, it is to use still continue using your PD mux.
Okay, thanks.
Thank you.
One thing regarding emergency communication, we don't have 100% coverage of CUG as of now in all the sections of Indian Railways. If the CUG coverage is 100% in all over India, all the sections, there is a discussion going on whether these emergency communication EC circuits are whether required or not. So once the coverage is 100%, that discussion when some output can come out of that discussion. So one solution may be that we can do away with the emergency communication. Okay. Yeah.
Linear paths can be protected using events again.
So unfortunately, we don't have anything to protect linear. You have to have redundant links, maybe of lower capacity to protect some kind of services, but you need multiple links to have protection.
Yeah, so linear paths can always be protected using a even from Railtel or somebody for your bare minimum. That's what we showed earlier in one of the architectures. That will be on your part of a design. Failure gets corrupted, the entire station will be down. There go will be continue.
Sir?
LER does not get corrupted. Yes, LER can go down because of a power supply failure or power supply fluctuation issues, but that also will be not much because you are using your own DC generated power. So that power supply issue is I don't foresee much of it. The only way LER can go down is either water or something enters into that area, which should not happen because of telecom hut. So the software corruption chances are very less, sir. But yes, if the LER goes down, you go down.
Just want to add, when you
Sir,
plan a network for how many?
1 minute, sir.
When you plan a network, you plan a network for how many failures are planning for network. 1 failure, 2 failure, 3 failure, and depending upon that, you need to add equipment or add links to that. So it's all a design question where we want LER protection, then put one more LER. If you don't want LER protection, link protection, put one more link. So it's all planning discussion when you want to plan the things. So it's nothing technology dependent. It's all planning
Design.
dependent discussion, design discussion.
Yes, sir. What is the question?
Sir, LER can also give the rise to 64 kbps even and Ethernet port also. LER.
Some of the interfaces of 64 kbps like RS232, E&M 485 or X.21 are all available on routers also. But then type of router will change because now you need to bring even into the LER as well as you want to bring sub even into LER. So the
Yes,
kind of LER router which we showed that only has one slot. So you need, if you have such a requirement, you need to take a router with bare minimum 2 slots plus your Ethernet.
Sir, instead of PDMux, we can put as LER also instead of PDMux.
You can put as LER also, yes. But we need to understand what is the type of connector you're using for your sub 64 or sub 2 even sub 2 Mbps connectivity.
Now, is there any interface for 64 kbps communication like control?
There are multiple interfaces: X.21, RS232, RS48, 484. There are multiple interfaces available. We will share the available interfaces with the Iriset team, and it's publicly also available. If one of those interfaces works for you, you can use that in a bigger LER, type 2 LER.
We'll be using RS232 or 485.
What is the power rating of an LER average?
Power rating I am not sure, but the power consumption of a LER router will be close to 120 watts, ideally. Okay. So any more questions?
Sir, backbone connectivity for MPLS is 10G or depend on traffic?
Sir, backbone connectivity as per RDSO currently is 10G. Not depending on traffic, it is 10 Gbps directly. Oh, chat also. Okay.
I already replied.
Oh, you're just replying. Sorry. There are multiple kind of alarm indication. Yes, so this is there on the physical box also. Also, you will have to buy an EMS, element management system, for your entire zone division, the way you take out the tender. But either entire zone can be a single EMS, element management system, which a single EMS can be purchased for the entire zone. From the EMS, we can give role-based access to each divisions. So, for example, division a group of members, like 3 or 4 members, will only have access to division A routers. So each division does not need to buy individual EMS. EMS can be single, and we can give role-based access and controls to different teams to handle their own area of routers and see their own alarms. Perpetual license. Usually we are all moving towards non-perpetual, but some of the applications is perpetual. Non-perpetual will save you cost. Perpetual will burden you with a lot of cost.
Essentially, when you go for a contract period of 7 or 8, after 7 years anyway, you have to refresh. You can always have a non-perpetual agreement.
Yeah.
There's no point in having an older EML and newer communication.
Technology refresh rate is 2.5 years. Of course, railways will run for 10 years. I'm not saying that, but no, this is core application also. You can't keep changing every now and then. But usually the technology refresh is now 2.5 years, which means in one cycle of 10 years or 12 years, there would be 2 or 3 refresh would have already happened. Distributor. Distinguisher.
We are configuring VPN, distributing RD, everything are P router. We are not touching any P router. And in what way your P router is to be higher than P router?
All the traffic support, if you go through the deployment, right? There are 10 or 12 P router rings will terminate on P router. That is the core router. So when we talk about resiliency, that is first in terms of hardware and in terms of switching capacity, right? So you are defining services at the edge, but the burden of carrying all those services to the next node lies on the P router, the core router. It is switching more traffic. It is defining protection for more number of countries. So all those things make it more ready. As I told you, service wise, feature set wise, B router and P routers are similar. You can define service on both the routers. But as per architecture, the core router is switching more traffic. So it has to be resilient. Suppose one P router fails, one LER fails, so one station is impacted. One core router fails, so 15 stations are impacted. So you need more resiliency. Cost is of the resiliency, not of the feature. I hope I answered you.
What is the model for P router by Alpha P router? What is the model?
The different models depending on requirements. Usually we
SWR, we are given ASR 920 as the PE router and ASR 903 or 907 as P router. So ASR 920 for PE router and ASR 903 or ASR 907 for P router. If you remove TDM, you can further optimize on the kind of routers. Over the time of period, TDM will be phased out by OEMs also. So it's just a matter of time. There are some questions coming on increasing the number of events. So you can increase the number of events, but the plan should be to phase out events.
Do you think that I am putting money into something which will phase out in next 2-3 months? I have to plan it accordingly. So I think we answered this PRS UST router question that you can have a service router, right?
Correct. So PRS, POIS, UTS, all these services separate routers are not required. Technically, you can converge all these services into LER, but what we suggest is to have one service router because of admin related challenges, configurations, resiliency to these services independently, and ability to not get into LER for configuration every now and then. Take a service router, one single service router, and use that service router and VRF Lite inside that to segment all different kind of applications. So PRS, FOIS, UTS, RailNet, everything will come into that one single service router. What about these routers after MPLS? So after some times, this life cycle of routers, you have to phase it out.
PRS router.
PRS routers, after a time period, you have to phase it out.
I think we have shown multiple options of connecting PRS and RailNet routers. There are option 1, 2, 3. These slides will be shared. I think you can go That's right. You can share. We already shared which one. With option one, two A, two B, connect using a service router. It all depends what benefit you want to extract. Each option has one certain advantage or disadvantage. So you can go as per the requirement.
Share. I'm not sharing.
Yes, changing here slides, but share slides, but share. No, you don't.
There's a question on PRS. There's a question on PRS routers. Why do you require PRS router or some router? So we have shown in option A, 1, 2, 3. There are multiple options.
They're not getting it. They're explaining it. I think the speed might be issues. Share once more.
You are not sharing.
Sharing it again.
Yeah.
Sharing your screen.
Yes, we are sharing.
Stop share.
This one is sharing. Very good.
I'll share again.
Now it was done. Now you share it.
Share it again.
Yeah.
Not sure. Share, try sharing from this.
क्या शेयर करना है PRS वाला?
हाँ, PRS वाला share. Sharing is not working from my box. Laptop is crashing.
कोई इशू नहीं, कर दो. शेयर हो गया. So on PRS. Is it visible on WebEx? Yeah. On there is a question on the requirement of a PRS router. So we have shown multiple options for connecting PRS or other services at station. You can have option 1 where you can directly connect to LER, but there are disadvantages which we discussed. We don't have a boundary to filter for a CEP kind of link for security and for admin purposes. You can build, you can put a service router, build more resiliency. You can put resiliency using an LER. So there are multiple options are there. तू अपने में कनेक्ट कर ले, मैं व्यवस्था शेयर करूँगा. इसको कनेक्ट कर ले, मैं व्यवस्था शेयर करूँगा. So any more questions, sir, on this PRS router? I hope I have answered. Question again? Question और है क्या? PRS I have answered. Okay.
Hello, excuse me, sir. Am I audible? Jaideep Pawar here from Southwestern Railway.
So you can take all the. Hello.
And am I audible?
Yes, sir, you're audible.
Yeah. Talk about technology refresh. You are on the both sides, PRS and the other organization, which is our core railway, which is having RailNet and other routers. Then why don't you have a combined network with the BGP running when they are having a OSPF with advantage of our BGP? Why don't we have BGP incorporated in them? Now there is no L3 switching allowed there, only L2. So what is your comments for this? And we could be able to create a protective paths within this available inventory itself. If we have this kind of same protocol running on both the when it is available in the stations, all the stations.
Correct, sir. You are right. So we can do that. Yeah, we can do that.
But there was a lot of resistance in the beginning. Only they wanted L2 VPNs, and they would not be open to sharing IP with the service providers and whatnot.
Correct,
So
sir.
now, since there is some technology officer in the CRIS who you must be in touch with, and having spoken with me now, if the policy is in place, the board policy is in place, we have already asked for certain migrations for UTN network. Why don't we have a combined similar BGP running? Because we are having some idle links always in the PRS, and they are never utilized because the OSPF, whatever global or local they are having, those are not able to use those links efficiently. With MPLS, we might be able to cut down on that.
Yeah, so we can definitely do this, sir. But we will need your help to have this one common meeting with Chris also. And as you said, we can, if we can eradicate OSPF and bring it all to the BGP, it will become much more efficient for us.
Now, second question,
Yes, sir.
you are having a technology refresh, whatever your records, 2.5 years or whatever. We are having even 12 years on similar 15 years routers still being indented. Why don't you do a buyback and say that this technology refresh will have the latest with the ACI configuration or whatever is available, so that we are able to have a software defined network. Now, all this is not being spoken because Chris earlier was not open, but now maybe they are open for a certain, little less mission critical other than PRS.
Yep, I think this is Pawar, sir. Sir, buybacks and all, I will definitely would like to. It's a good suggestion, but definitely I will engage my sales teams to engage with for these discussions. And it's a good point, but technically it's not in our control. But we'll engage with sales to look at the buyback options, sir, as suggested by you, and we'll work on that.
Thank you.
Thank you, sir.
Okay, if there are no more questions, we'll close the session. Before closing, I appreciate the interactive session, and with having participation more than 460 numbers, I thank Cisco systems team who has come to reset and gave this informative and interactive session led by Shri Sumit Ranjan, Shri Binu Nair, and Shri Ravindra Reddy, and which the participants ranges or level of participation was from JE to HAG. All level were there, and questions were asked which benefited all. From 2:30 hours, we have IPv6 session that is again held by ERISET, which will be helping migration from IPv4 to IPv6. That will be in a dual stack arrangement. ERISET has done it, and recently Western Railway also has done it. I congratulate Western Railway for having dual stack with of IPv4 and IPv6 in Western Railway. And I thank again the Cisco team, and whoever wants to join the IPv6 may please join at 2:30, 14:30 hours. With this, I thank all and I now close the session. Thank you all.
Thank you, sir.
Thank you, sir. Thanks a lot. So thanks everyone who joined on the call. Thanks a lot. These are our email ID. In case any further query, you can reach out to us and we can revert on that. Thank you very much.
Thank you.